Alright, this is Precalc Concept 34B. We're going to look at a couple applications of the law of sines, which are basically word problems where knowing the law of sines is going to be really useful for solving some things that you might encounter in the real world. We'll jump right in with an example here. So the Leaning Tower of Pisa, most of you have heard about, turns out to be leaning at an angle of about 84.7 degrees. And it question asks, if you walk 171 feet from the base of the tower and you measure the angle of elevation, you could actually tell the height of the tower. So this is a problem you've seen before in many examples where you had a building or a tree or something that was standing straight up, and so you had a 90-degree angle, and you could use SOHCAHTOA and solve that pretty easily. So the big difference here is that the angle the building forms with the ground is not 90 degrees. Your building is not straight up and down. And so your SOHCAHTOA ratios won't work. Right? So if you're thinking, couldn't I use tangents to solve this problem? You could if it was a right triangle, but since it's not, you can't. Alright, so I'm going to look at my diagram here and think about my unknown, which is B, and think about the angle that's across from it. And right away I can set up a ratio because I know that the sine of 50 over b is going to be the same as any other ratio in the triangle. The 171 is a given piece of information, but notice I don't know the angle across from it. Good news is I can figure that angle out pretty quickly. So if you pull out your calculator and do a little calculation there, 180 minus 50 minus 84.7 turns out to be 45.3. And so now that I know angle C, I can set up my second half to the law of sines, which is the sine of 45.3 over 171. And that's it. That's your law of sines ratio setup. I'm going to do the solving by cross multiplication again. So b sine 45.3 equals 171 sine 50. And b, as a final answer, is going to be 171 sine of 50 degrees divided by 45.3 degrees. I'm getting a little sloppy. I should be putting degree measure on all these angles just to remember that I am in fact working with degrees. My final answer that I get from my calculator turns out to be 184.29. This is a classic example of indirect measurement. Without actually climbing to the top of the building, I can find how tall it is by thinking about some related lengths and angles. Alright, example 2 is a track and field problem, my favorite. Alright, it talks again about an example of indirect measurement. So down there at point A, you have a guy throwing a shot put, and he's going to throw it a length, a distance that's going to be the C in my triangle. And rather than getting out a tape measure and measuring from A to B directly, there are actually devices that can measure the angle from maybe right next door to the throw, or actually in this case really far away. So in my picture here, we've got an angle that's across from side C, which is 5.7, and then another angle that I'm able to measure from the end of the throw back up to the observer, and the final thing is that the distance from the observer to the beginning of the throw was 562. The picture here helps us out a lot because really it's just a triangle, and I know a bunch of stuff, and there's only one thing that I don't know, which is side C, and I should be able to use the law of sines to solve this. So let's jump right in. If I take the sine of the angle C, 5.7 degrees, and I divide by side C, which I don't know, I should get the same ratio as the sine of 85.3 degrees divided by the the side across from it, which is 562. C times the sine of 85.3 is equal to 562 times the sine of 5.7 degrees, and the expression for C then is going to be 562 times the sine of 57 degrees divided by the sine of 85.3 degrees. And pulling out my calculator, typing all that in, I get a value of C that's about 56.01 feet. And once again, without actually marking or measuring off the actual distance of the throw, but rather by looking at related angles and lengths, I can find the value of C indirectly. Okay, here's one more you try. I'm going to let you read this problem. Read it carefully, think about the values given. The picture is a big help. Figure out what you need to find and see if you can use the law of sines to find it. Okay, hopefully you realize that the side across from C is what we're trying to find. I called it X, you could call it C or any letter you choose. And hopefully you'll also realize that the third angle there is important to find. Once I find that third angle, I have a angle opposite side pair. So sine of 65 over 300 equals sine of 53 over X. And solving through using your calculator, you get a final answer of 264.4 yards. Another great example of indirect measurement without swimming across the river. Just knowing the distance between A and C and some angles involved, I can actually figure out how far it is from point A to point B.